Here in Lecture 2, we're going to take a look at how to declare and use function pointers and why these are useful. We'll also take a look at defining type names using the typedef keyword. And we need to say more about const as it pertains to data members and member functions within class objects. We're also going to introduce the idea of const pointers. Okay, so we know that the name of an array denotes the address of the initial element of the array. And we've seen that we can set up a pointer variable initialized with the address of the initial element of an array, and then use that pointer variable to step through the elements in an array. It turns out that a function name denotes the address of the function, and you can set up a pointer to function object or variable to keep track of the address of a particular function. Now, the type of the pointer to function has to match the type of the function. For example, here on slide 3, and here we need to remember our inside out, right then left rule. This is an extension to that rule that we already talked about in context of arrays and pointers. PF here is a variable whose data type is pointer to function taking int and returning bool. Now, following our right then left rule, we start with the name of the variable, PF. We attempt to read to the right first, but we hit the closing parenthesis, so that reflects us back to the left. So we read the star as pointer to, and there we've bumped into the left parenthesis, the open parenthesis, so that jumps us back to the right again. And here, instead of a square bracket, which would indicate an array, we hit an opening parenthesis, which indicates a function. Now, you're probably accustomed to thinking of the open parenthesis as simply part of the syntax for a function definition and a function call. But in fact, the parentheses are an operator. They're called the function call operator. And so the opening parenthesis here tells us that PF is a pointer to a function. And then continuing to the right, this is a function that takes an int as its argument. And in fact, that's its only argument, because now we've hit the closing parenthesis at the end of the function argument list. And the function returns bool. Okay, so again, what that statement says is that PF is a pointer to a function that takes an int as its argument and that returns bool. In the bottom half of slide 3, we've defined 3 functions of this type. GTR0 takes an int as its argument and returns bool. What GTR0 does is to return true or false, depending on whether its argument is or is not greater than 0. So if I is greater than 0, that function will return true, otherwise it will return false. The second function, 0, is a function that takes an int and returns bool. And in particular, it will return true if its argument is exactly 0, otherwise false. And the third function, prime lt10, takes an int and returns bool. It tests whether its argument is a prime number less than 10. And there are only 4 prime numbers less than 10, 2, 3, 5, or 7. So if the argument is one of those values, 2, 3, 5, or 7, this function will return true, otherwise false. All right, so we've got a pointer to a function that takes int and returns bool, and we have 3 functions that take int and return bool. We can use that pointer to point to any one of these 3 functions that we've defined. Here on slide 4, we have an example program making use of a pointer to function variable named PF. This PF is a local variable within the main function. PF is a pointer to a function that takes an int and returns bool, it's being initialized with greater 0. So PF is currently pointing at the function greater 0. Now, these functions all return true or false, and I would like to see those words true or false as opposed to the numbers 1 or 0. So I'm going to use my good old bool alpha manipulator to turn on displaying Boolean values as words. And to call the function that PF is currently pointing to, I can dereference or do an indirection on PF with the star. We need to enclose that in parentheses because the function call operator, the opening parenthesis around the J, actually has higher precedence than the star. So you may recall that if we had a pointer to a struct and we wanted to access a component of the struct, we would say star of the pointer in parentheses dot and then the component name. Well, here we're saying star PF in parentheses and then parentheses J to indicate that the value of J is the argument that we want to pass to this pointed to function. Okay, well, J's value is 7, and consequently, when I pass 7 as an argument into the function that PF is pointing to, which is greater 0, that function will return true, and so true is what's going to be displayed on my screen, as we see here on slide 5, showing the output of the program on slide 4. It turns out that as a shortcut, you can leave off the star in front of the pointer and simply use the function call operator right after the pointer variable, and that will also be interpreted as a call of the function that the pointer is pointing to. So here again, we're calling greater 0 with 7, which again is going to return true. Next, I'm changing the value of PF to the address of the function 0, and so now when I call the function that PF is pointing to with 7, that's going to return false because of course 7 is not 0. And then finally I'm saying PF gets the address of this function prime less than 10. This time when I call the function that PF is pointing to with 7, since 7 is a prime number less than 10, we get back a true. Okay, so this is a very simple example of setting up a pointer to a function where we have to specify the types of the arguments and the return type for the kind of functions that this pointer can point to. And then we've set up this pointer to point to 3 different functions in succession, greater 0, 0, and prime less than 10, and called the function through the pointer. So who cares? This may just seem like a stunt. Well, basically, an important idea of function pointers is to associate an action, that is, associate some function call with some event that occurs. For example, if the user presses a key on the keyboard, that may cause a function to be called. If you're monitoring stock prices and the stock goes above a certain threshold, that can trigger a function to be called. If you have a wind speed monitor that's connected up to your computer and you detect that the wind increases or decreases by a certain amount, that can trigger a function to be called, and so on.